The main idea for paper 4, sorry, the main idea for paper 4 M1 is based upon knowledge of physics, and we can use this knowledge in solving questions in the syllabus. Start of the syllabus, examiner has highlighted some formulas, some trigonometry unit conversion like this. Look at them, and I hope you remember all of them. Look at them. These are the conversions you will need in M1 also. We have recently finished this chapter, and I hope you remember all of them. So give a heading Introduction to M1.
Okay.
Introduction to M1, and copy down this blue box first of all.
Done.
Now, our first chapter is forces and equilibrium. This is, we can make a list here. You can just write down the title for number 1, make a side heading, unit list of topics, give a side heading, list of topics. Sorry. Number 1, forces and equilibrium. Number 1, forces and equilibrium.
Done.
Number 2, kinematics. Number 2, kinematics.
Kinematics. Done.
Number 3, momentum.
Done. Done, sir.
Number 4, Newton laws of motion.
Done.
Number 4, Newton laws of motion. And number 5, energy, work, and power. Now, as mentioned, the same that we have now 5 topics in mechanics. They are all based upon physics. Partially, they are coming from O-level physics, and some topics, some knowledge points are from A-level physics. But definitely, it's smaller than P1. And I think you told me that you have done physics O-level, right?
Yes.
So we can start our title work, and I have shared the syllabus with you on the chat. Now I'm starting with vector analysis. Can you please manage this? Your microphone making a very strong sound.
Okay.
Because it is incoming between. Please now give a heading. This is our first title to discuss vector analysis. Vectors are directional quantities, as mentioned that we are taking knowledge from O-level physics. So give this is our first topic. Give the heading vector analysis. In M1, this is our first title. Vector is the core topic in M1. You can see that a good percentage of M1 is based upon vectors. There are total 5 chapters in M1, and at least four of them are using directly the vector and scalar knowledge. Now I connect with our O-level physics. And what are scalars and vectors? What are scalars and vectors?
Scalar quantity is a quantity that has a direction, and vector quantity does. No, sorry. Scalar quantity does not have a direction, and vector quantity does have a direction, magnitude, and size. No,
Scalars
no,
are
not size.
those quantities. Scalars are those quantities which contain a particular direction. And what about vector quantities? They are those quantities which are having particular. Scalars are without direction, and vectors are with direction.
Direction.
You can recall for me any example.
Displacement and distance. Distance is scalar and displacement is vector.
Distance is a scalar and displacement is vector. Good. Okay. Just a minute, please. Screen sharing is getting a problem. Scalars and vectors, and as mentioned, scalars are the quantities which can be explained completely without direction, like mass, volume, time, etc. Vectors are the quantities which cannot be explained completely without direction, like force, acceleration, and velocity. Let's talk about vector analysis in our course. The main idea, there are three main versions, three main topics under this title of vector analysis. One is called resultant vector. One is called the resultant vector, which is addition of vector. Second is subtraction of vectors, when you subtract two vectors. And the third is equilibrium of vectors. Now you have to copy this screen.
Sir, I didn't copy the previous screens.
No, that's not needed. You know the definition. So obviously we are not, this is not a physics subject, na? So definitions do not come in M1. You have the
Okay.
concept you told me, and this is a way to proceed. Obviously, we're not making notes like for physics. So you have to copy this screen. There are 3 topics under this title. The main, you need to remember some titles, some topics, physical quantities as scalars and vectors, which I will share with you so you can remember them, that there are scalars and vectors.
Sure.
Now these are 3 main topics in vector analysis. Now give a heading, concept of a resultant vector. What is a resultant vector? Suppose 2 people are pulling a substance like a table, their forces are added. Like a tug war where people are opposing the forces, the resultant is the subtraction of the forces. Resultant force or resultant vector, when 2 or more coplanar vectors are acting on an object, the final output vector is called the resultant vector. To copy this screen. Resultant vector is one of the most important concept in M1.
Done.
So this is the concept of resultant vector. Again, remember, we are using the idea of physics. So physics should be helping here. Look at the rule number 1. Look at the rule number 1. Look at the rule number 1. Vectors in opposite direction are subtracted. Vectors in opposite direction are subtracted. You have to copy this.
Done.
Now, I hope you remember it, right? Because you have done this.
Yes.
When vectors are when vectors are in the same direction, they will be added. What's the rule? Vectors in same direction are added. Copy rule number 2.
Vectors in same direction are added, right?
Do not repeat it. Vectors in the same direction are added. Rule number 3. Have you copied it?
Yes.
Now, rule number 3. This rule, the two vectors are perpendicular. Look at the diagram. When vectors are perpendicular, you have to redraw the diagram. You have to make a head to tail diagram and then use Pythagoras to get the magnitude. Now you have to copy rule number 3.
Done.
Now, what is the method? Redraw the diagram, joining the vectors head to tail. This is a special terminology used for vectors. And the idea is there that we will make a right angle triangle and then we can use the properties of right angle triangle. You have to copy this screen.
Sir, can you go to the previous slide? I want to copy the workings.
Just wait for it. It's coming after that. Redraw the diagram, joining the vectors in head to tail. Now, once you join it head to tail, you will get a right angle triangle and you will use Pythagoras theorem for magnitude. You have to now copy this.
Done.
Now, tan theta is equal to 5 upon 7. I hope you remember that tan theta is opposite upon adjacent. Tan theta is opposite upon adjacent. So I'm using that. And then I will use my calculator to find the theta. Remember, theta is for direction. You have to copy this.
So like it's going 36.5 degree towards.
You can see the angle theta marking.
Yeah, but it's going 36.5 degrees towards northwest.
No, just look at the angle. Class 6 angle is marked theta. So it
Yeah.
means this is 35.5. That's simply that. Nothing north, nothing south, nothing like that. It's simply the angle. Simply the angle.
Okay.
Have you copied it?
Yes.
A vector has always two important parts. One is the magnitude and second is the direction. So whenever you are dealing with a vector, you have to remember the vector has two main parameters, magnitude and direction. You have to copy this.
Done.
Now we move to our methods. Addition of vectors, which are actually the idea is to get the resultant vector. The methods are number 1, parallelogram method. Number 2, graphical method, which was in our O level also. Number 3, resolution method. There are 3 methods which are actually available. You have to copy now. The list of methods.
Done.
Now, the parallelogram method is limited for 2 vectors. In physics, it can be done by graphical work, by the working on a using a geometry box, and also you can use a calculation method. In physics, you can do both methods. In M1, you cannot use a scale drawing, which means the protractor and the compass method. In physics, they allow only the method of calculations. So now copy this point that this method, give a heading, parallelogram method, and write under it that this method is used for 2 vectors.
Done.
Now, this is a sample that how this question appears. Look at these 2 vectors and the angle between them is the resultant force. We need to find the resultant force. Now copy this diagram screen.
All right. Done.
Can you please manage the mic, please? Actually, it's producing a very huge sound.
It is easy to construct a parallelogram when we know the lengths of its sides. This can be done by drawing a straight line parallel to the first vector and passing through the end of the other vector. Then, in a similar manner, we draw a straight line parallel to the other vector and passing through the end of the first vector. Now, we draw a vector of the resultant force. Its origin is located at the point where the common origin of the 2 vectors is located, and the end is marked by the point where the straight lines intersect. The construction results in a parallelogram whose sides are the component force vectors and whose diagonal is the vector of the resultant force. It is easy to construct a parallelogram.
There are 2 possible ways. Number 1, by drawing. Number 2, by calculation. We will follow the calculation method. In old versions, there was an option, but now CI says that you can't use this method. So it's only for knowledge here that this is a method. And we will focus on calculation method. You have to now copy this screen. Have you
Done,
copied it?
sir.
Good. Now we are leaving the scale drawing approach, and scale drawing approach is not in our course, M1. And we are moving for calculation approach. You need a calculator, obviously, and mentioning again that keep one notes register for M1 and one notes register for P1. And questions you should not do in any of these registers. You can do on your copy. Ideally, solve the questions on the past paper books you have just got. Now give the heading calculation approach.
Done, sir.
So it is a concept of triangle. Originally, it's a parallelogram. I'm putting my first example and I am marking the angle and I need to find the resultant force. You have to copy this example.
Done.
Now I'm starting this work. I'm first drawing 50 Newton line. So you can work with me. No scale drawing, just like draw this line 50 Newton. Draw this line 80 Newton at an angle of 70 degrees. Now I'm constructing a line parallel to it. So now copy this with me.
Yes, done.
Now I'm shifting this angle 70 here. Can you tell me how come 70 comes here?
It's a corresponding angle.
It's a corresponding angle in parallel sides.
Yes.
Now 70, I'm making a green dotted line. This is my resultant. And I'm bringing the angle inside. Now it is 110. This is the resultant which I need to find. So update the diagram with me.
Done.
Then I'm going to apply cosine rule for the magnitude of R. I have simplified the triangle. And now this is where I can find the resultant force. So now you also have to copy the same and try to solve for me.
Done. Can I just solve?
Yes, please go ahead.
Sir, are we done with differentiation?
We have started in our last class. We have
Yeah,
started. We have
okay.
started.
Okay.
So differentiation is our main topic, but we need to start M1 along it. If we have the classes, we can divide them 2 classes for M1. And you just try that do not take any off because the time is actually extremely less.
Yes, and sir, I wanted to discuss that I still have 2 extra classes. Can we adjust that?
No, the point is that first we make a regular. For direction, we are going to use sine rule, and you had a calculation. And this was the calculation screen. Please share your answer.
Hello? The answer is 43.6 degrees.
43.6.
6.
Perfect. Good. Apply cosine rule for magnitude. Apply sine rule for direction. You have to copy this screen now.
Yes, and also wanted to ask you one thing. Is it always better to use um just say like in the last example, I used 108. I didn't use 107.8. So is it always to use
No,
the
no,
round off
I got the
number?
question. It's always better. It's always better to proceed with unrounded answer. Do not proceed with rounded answer in the next part. So if you got in the previous part, you got 107 point something, it better use that. Do not use rounded answer in the next part.
Okay.
Now copy this screen. For
Done.
For magnitude, we use cosine rule, and for the direction, we use cosine rule.
Yes. I'm done with this.
Now let's try our second example. Look at our second example. So please copy this example and try to solve it.
Okay.
Have you copied the question?
Yes, I'm solving it.
Good.
Okay. So for the resultant force, any side, I got the answer 1160.26.
I'm getting one more.
And for, sorry?
What
Yeah.
value you?
And for the theta, I got 17.5 degrees. Or 17.6 if you round it off.
Right. Now give the heading graphical method.
Done.
Copy this screen now that now look at this concept. This is called head to tail method. In our O-level physics and O-level maths, this topic was there. Uh, Head and tail, these were the vectors. Every vector has a head and a tail. When you join them, you have to join them in such a way that head and tail come together. The resultant is always head to head. You have to copy this. Do you remember head to tail?
Yes.
Good.
Done.
Look at this sliding. It is head to tail approach. The vectors must be joined head to tail. The vectors must be joined head to tail to get the resultant. So vectors being added are connected head to tail, and the resultant vector is head to head. You have to copy now this screen.
Done.
So we keep it up to here. And inshallah, we'll continue in our next class. Allah Hafiz.